We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating "match not found" message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
A Dyson sphere is a theoretical megaproject, a ginormous sphere encircling a star with platforms orbiting in tight formation. It's supposed to be an ultimate solution both for energy production and living space. The creators of a Dyson sphere get a lot of surface area for habitation and the ability to catch every tiny bit of solar radiation and heat produced by their central star. The first person to theorize about such a bizarre construction was British-American theoretical physicist Freeman Dyson. According to him, an intelligent extraterrestrial civilization could consider building this sphere after colonizing some moons and planets in their local stellar neighborhood. With the growth of their population, these aliens would need more and more energy to sustain their lives. Dyson calculated that assuming that this alien society grew at 1% per year, their area and energy needs would become 1 trillion times larger in a mere 3,000 years. And if their solar system contained a space body similar in size to Jupiter, they could take it apart and spread its mass in a spherical shell by building a structure at twice the distance between our planet and the Sun. This amount of material would be sufficient to build a huge number of orbiting platforms. Each of them could be 6 to 10 feet thick, which would basically allow this civilization to live on their star-facing surfaces. A shell this thick could be comfortably habitable and capable of holding all the equipment needed for using solar radiation without falling onto the star from the inside. But after absorbing all this solar energy, the sphere would have to re-radiate it. Otherwise, the energy would build up, eventually causing the construction to melt. It means that the light of a star wrapped in a Dyson sphere would look dimmed or even completely darkened, depending on how dense the platforms orbiting it were. At the same time, it would glow unusually bright in infrared wavelengths invisible to the unaided eye. Because of this infrared radiation, Dyson spheres are classified as a type of technosignature. It's a sign of activity that astronomers can use to discover intelligent life forms in the universe. Some Earth-based researchers have infrared maps of the night sky they examine in hopes of spotting Dyson spheres. So far, no one has ever found one. However, one study has selected several Dyson sphere candidates. Its authors have processed large amounts of information using a special data pipeline for combining and analyzing information. One of the main search criteria is the detection of excessive infrared radiation. At the same time, it's important to distinguish this radiation from that emitted by natural objects. After a complicated filtering of millions of objects, the researchers identified 7 potential Dyson spheres. Sure, further analysis is needed to determine their nature. To do this, scientists want to use optical spectroscopy, which may reveal more details about these objects and their origins. At the same time, the researchers admit that these candidate Dyson spheres might have other explanations. For example, they could be debris disks or protoplanetary disks of young stars. Only more research can show whether we can find traces of other civilizations among star systems. For now, it's still an open question. Interestingly, Dyson spheres have been spoken about a lot in science fiction. As far back as 1937, a novel called Star Maker by Olaf Stapledon described systems in one particular galaxy that were surrounded by a gauze of light traps, which focused solar energy for intelligent use. That was the reason why the entire galaxy was dimmed. In another novel, Ring World, the writer spoke about a ring-shaped artificial structure surrounding a star.
We almost know what happened right after the Big Bang. Scientists understand the universe really well from about 1/1,000,000,000th of a second after it all started. But what about before that? That's where everything gets fuzzy. First of all, we need to remember that our universe is constantly expanding. You can imagine such expansion as inflating a balloon. We know the equations that describe the expansion of the universe. These are the equations of Einstein's general relativity theory. They state that the presence of matter in the universe leads to its expansion. And just like a balloon is inflated at different speeds by hot and cold air, the speed and character of expansion of the universe depends on what type of matter dominates. Slow particles, hot relativistic matter, or even mysterious dark energy. So if you imagine his expansion as galaxies just flying away from an explosion, you need to rethink it. By the way, the Big Bang wasn't actually an explosion, so instead, space itself is expanding, pulling galaxies along with it, kind of like corks floating in a stream. This movement is what we call the cosmic flow. Space is like an elastic medium that stretches, carrying everything with it. Physicist John Archibald Wheeler found a great way of describing it. Matter tells space how to bend, and space tells matter how to move. Basically, the stuff in the universe and space itself are in constant interaction. In general, expansion is an important property of the universe from the very beginning. But how do scientists study what happened to the universe billions of years ago? We cannot look directly into the past. Fortunately, there are indirect ways. When the life of the universe began, it was almost homogeneous, and galaxies appeared from small unevenness. In other words, the distribution of galaxies in the universe shows us the unevenness of matter in the early universe. Another super useful tool is cosmic microwave background spectrum analysis. Let me explain where it came from. At first, the universe consisted of plasma, which is charged particles. Light cannot spread through such a substance because light is scattered by charged particles. It's similar to when we are running through a forest. We have to dodge trees. At some moment, positive and negative charges united, and the universe became electrically neutral. After that, light particles could easily move through it because they had nothing to scatter from. It's as if you were running across a field and not through a forest. So the radiation that was at the moment when the universe became electrically neutral reaches us without problems. It's as if we have a photograph of the early universe. This is a real treasure trove for scientists. Now, when physicists don't have enough data, they use models to make educated guesses. Because in addition to the cosmic microwave background and the distribution of galaxies, there are other indirect observations of various stages of the evolution of the universe. And those different models physicists study must pass all these numerous tests to describe the observables. Then, if we have a model that describes the evolution of the universe, we can use it to understand not only how the evolution of the universe occurs, but also to look into the past. What was its state in the earliest stages? Well, things were extreme. The universe was small, matter was squeezed, and the temperature and pressure were sky high. Go back far enough and you'll hit a point where everything is just a super hot, primordial soup of elementary particles zooming around and smashing into each other. At the time, atoms didn't even exist yet. Even more exciting, today's observations predict that even earlier, there was a stage of very, very rapid expansion. Almost instantly, the universe expanded many, many times. Such fast expansion is called inflation, and it might explain a few big mysteries that cosmologists struggle with. For example, why the geometry of the universe is so perfectly flat instead of curved. Then, there's the horizon problem. How is it that the temperature of the cosmic microwave background, the afterglow of the Big Bang, is almost exactly the same no matter where you look in the sky? And finally, it can help us understand what caused the first tiny clumps of matter, which eventually led to galaxies, stars, and planets to form. Inflation solves these problems because the rapid expansion it proposes would have smoothed everything out, explaining the universe's flatness and even temperature, while also allowing tiny quantum fluctuations to seed the first galaxies. But scientists are still working with other models and theories. So while this idea answers some questions, it doesn't give us the whole picture. There's still much we don't know. But by exploring this and other theories, we're getting closer to understanding how everything began. As we have already found out, the presence of energy in the universe leads to its expansion, and for the expansion to be so fast, a lot of energy is needed. And apparently, this energy came from some unknown field. We know that there might be new forces or particles that only show up at super high energies, but we haven't found them yet. This is where the inflaton field idea comes in. It's the most popular theory to explain the early universe. The inflaton is a field that might have caused the universe to expand incredibly fast in an event called cosmic inflation. Where could this field come from? The standard model of particle physics says there are 12 basic particles of matter, 6 quarks and 6 leptons. The most famous are the up and down quarks, which make up protons and neutrons, and the electron. All the elements in the universe are made of just these 3 kinds of particles. And then we've got the Higgs boson, which gives particles their mass. The amazing thing is that this particle model explains what the universe was made of in its first trillionth of a second, after the Big Bang. But naturally, we want to go even further back closer to the actual Big Bang moment. Unfortunately, Or perhaps, fortunately, we can't recreate the crazy high energies that existed at the start of the universe in any experiment. We have tested our particle physics theory. Only up to the energies that the Large Hadron Collider produces. What happens at higher energies, we can only guess. So scientists have to build their ideas based on what we know. They use the theories of quantum fields to imagine what could have happened at those extreme energy levels. It's not random guessing, though. These theories help us figure out how particles would behave at higher and higher energies. Perhaps one day, our particle physics will be supplemented with new particles that are responsible for inflation.
Imagine you've booked a tour through the jungles of Costa Rica. All of a sudden, you stumble upon a huge stone sphere, nearly the length of a king-sized bed in diameter. How on earth did it end up there? And what does it symbolize? You immediately ask your guide. He's not as amazed as you are, and tells you that there are actually several hundreds of them scattered across the south of the country. The mysterious stone spheres don't have an official name. The locals simply call them las bolas, which means balls in Spanish, while historians refer to them as Diques spheres, after the culture that produced them. Scientists have studied the sediment layers of the Earth around them and estimate that the earliest were made around the year 600 CE, and the newest ones date to the year 1000 CE. Many of the spheres were relocated after their initial discovery, and that's why archaeologists can't date them precisely. The Diques culture completely disappeared shortly after they were discovered by the Spanish in the 16th century. Unlike the Mayas and the Aztecs, the myths or legends of these peoples didn't survive, so they cannot explain the existence of the mysterious orbs. More than 300 of these objects have been discovered so far, with some being smaller than 1 inch in diameter, and the largest measures 6.6 feet in diameter, standing taller than most humans. Although there are ones made from limestone, most spheres were carved out of a coarse version of basalt, a type of rock that forms when lava cools rapidly. Some orbs weigh up to 15 tons, and in most cases, their surface is smooth to the touch, although there are coarse, mostly unfinished pieces. If we throw away the theory that river erosion naturally sculpted the spheres, the ancient people seem to have created them by hammering boulders with other rocks. Once they got the rough shape they were aiming for, they would polish the rock to perfection, using techniques such as controlled fracture and grinding. The mysterious spheres are located in the Diques Delta, on the coast of the Pacific Ocean. Most of them can be found in a place called Farm 6, which, alongside 3 other sites, was proclaimed a UNESCO World Heritage Site in 2014. The area contains other finds from the pre-Columbian era, such as paved areas, burial sites, and mounds. For centuries, the stone balls were hidden under a thick layer of sediment that protected them against the elements and looters, until they were unearthed during the 1930s. The company that owned the land was clearing the rainforest for banana plantations when they stumbled upon these unusual stone constructions. Some were damaged by bulldozers, and some by workers trying to pry them open, as they believed there was gold hidden inside. It took a while before the authorities intervened to stop further damage to the finds. Doris Stone, the daughter of an executive of the company that owned the land, was the first to study the spheres. In 1943, she published an article in a leading American archaeological journal, turning the world's attention to the orbs. Expeditions soon followed, and archaeologists were immediately able to determine that the stone formations were human-made, probably created by the ancient indigenous population of Costa Rica. To this day, no one has been able to fully explain their function in a scientific way. It means there's still room for some wild theories about the sphere's origins and true purpose. The most popular theory in the scientific community is that the stone spheres served as decorations and status symbols, as many of them were found near the houses of chieftains. Local tribal leaders were also laid to rest with some of the smaller balls, so these stone formations were definitely associated with power in some way. Chiseling a boulder to perfection involved a lot of labor and planning, and only powerful individuals could afford it at the time. The other popular theory is that the boulders were used for astronomical observations. Individual spheres represented stars or planets, like a primitive map of the night sky. Since they were perfectly round, it was easy to roll them around. Before the jungle engulfed them, the area where they were found was a flat alluvial plain, ideal for rolling large boulders around. Another version of this theory suggests that the stones were used as boundary markers, much like modern border stones, which are also mostly made from stone. Finally, legends from other tribes that lived in the area tell of how the spheres were cannonballs that the deity of thunder used to drive away the deity of winds and hurricanes. We still don't know the original purpose of the Costa Rican spheres, but they remain an important part of the country's national identity. The National Museum in the Costa Rican capital, San Jose, has 6 of them in its courtyard. Many other spheres have become prized garden decorations for wealthy Costa Ricans. There's even one at Harvard University. More than a millennium after they were created, the mysterious stone spheres of Costa Rica are still associated with power and wealth. In terms of numbers, the stone orbs are not perfectly round. They are rated as nearly perfect, at 96% spherical in shape. And while even that is pretty impressive, the spheres of Costa Rica are not the only ones of their kind. Nearly a decade ago, workers came across mysterious giant stone spheres deep underground in a coal mine in northern Asia. The surface of the spheres, which measured a little over the length of a human footstep in diameter, was unusually smooth, and people tried to explain it somehow. Some were certain they were out of this world, and others suggested the spheres were actually petrified dinosaur eggs. Scientists quickly put an end to further discussion, as it turned out that the mysterious spheres were concretions. Those are rock formations that take millions of years to form deep underground. Think of a pebble that picks up snow as it rolls down a hill. That's how concretions are made. Groundwater, rich in sediment and minerals, flows around the sediment, slowly shaping it into a perfect orb. The process is quite common in nature, but most concretions are fairly small. The spheres found in the coal mine grew to their size in the mineral-rich ground, and they were big enough to get the press and the general public interested. Another possible case of concretions is the massive stone spheres found in the Visoko Valley in Bosnia. Samir Osmanagic, better known as the Bosnian Indiana Jones, was the first to explore those objects about as wide as the length of a London bus. He believes the stone spheres were carved by a lost civilization that lived in the area 1,000 years ago. The reddish color of the orbs, though, is proof to geologists that they are indeed concretions, rich in iron content. The Moki marbles, found in rural Utah, are similar in color to the Bosnian spheres. These tiny concretions are the size of toy marbles and consist of a sandstone core and a shell made out of hematite, an iron ore. In South Africa, miners have come across Klerksdorp spheres, which are similar in shape and size to Moki marbles. The only difference is that these ones formed inside volcanic sediments and ash. The most intriguing among human-made tiny spheres are probably the orbs found on several Greek islands. Scientists discovered 700 stones smaller than golf balls near the Bronze Age site of Akrotiri on the island of Santorini. They believe that the finds were between 3,600 and 4,500 years old. When they compared all the stones' variations in size and color, the archaeologists concluded that these enigmatic stones could have easily been the oldest board game ever made. With the help of artificial intelligence, scientists are now trying to work out the rules of this game.
Guess what? Scientists have come up with a cool idea about some cosmic creatures saying hello to us from the center of the Milky Way. Astronomers are all excited about finding extraterrestrial life, so they're focusing their search right at the heart of our galaxy. Imagine stars in outer space, like super cool DJs, spinning their own unique beats. But instead of music, they send out these special signals called radio pulses. It's their way of saying, "Hey, what's up, universe?" These radio pulses are basically little bursts of energy that travel through space. They're not just random noise, though. They have a specific pattern that makes them stand out from all the other sounds out there. It's like a secret code or a special rhythm that only these stars know how to create. Scientists are super curious about these radio pulses because they think that maybe, just maybe, intelligent beings from other planets could be using them too. It's like a galactic language that they could use to talk to each other. So, these clever scientists created special tools and software to listen in on these signals. It's kind of like tuning into your favorite radio station, but instead of music or talk shows, they're trying to catch these cosmic beats. They're hoping to find those unique patterns that could be a sign of other space beings trying to communicate with us. They used a super cool telescope called the Green Bank Telescope in West Virginia to collect data and search for these signals. But here's the twist. They didn't find anything this time. No worries though, because their fancy software is lightning fast and it'll help them search even better next time. But why did they pick the center of the Milky Way for this ET life hunt? Well, that's because the galaxy's hearts are packed with stars. In other words, there should be many more planets in there, which means more potential places for life. Plus, if there are super smart life forms at the core of our galaxy, they could easily send signals to lots of planets all at once. Sneaky, huh? This whole thing is super exciting because it's the first time scientists have gone all out to search for these types of signals. They think that using specific frequency ranges and repeating patterns is a really clever way for ET beings to make themselves known. I mean, that combo is so unlikely to happen naturally, right? The best part is that they have this algorithm thingy that can go through a crazy amount of telescope data in just 30 minutes. So, even though they didn't find anything yet, they're confident that this speedy method will help them find evidence of advanced life in the future. How awesome would that be? As you know, humanity has been searching for buddies from outer space for a very long time. This research is just one of many attempts to find them. There's a whole institute dedicated to this mission in the US, SETI, or Search for Extraterrestrial Intelligence. So, naturally, the question arises, why haven't we found anyone yet? It's like we've been scanning the sky forever, hoping to catch a glimpse of advanced civilizations out there. But we get absolutely nothing. All this brings us to the famous Fermi paradox. It's like a big mystery that fuels the hunt for extraterrestrial intelligence. We think that if intelligent life exists, we'd have evidence of it by now. Maybe they're actually beaming out radio signals for us to pick up. Or maybe they're just broadcasting in general and we happen to stumble upon it. They could even have left cool artifacts in our solar system to keep an eye on us or just hang out. Heck, maybe they're building wild mega engineering projects, like gigantic solar panels around their stars. Or they could be getting all fancy and contaminating their stars with heavy metals just to announce their presence. So the search continues. We're not giving up just yet. And hey, maybe instead of just focusing on smart space beings, we should be on the lookout for any kind of life at all. Yeah, I know that a tiny microbe might not be as thrilling as chatting with friendly otherworldly creatures. But think about it. There could be lots of simple life forms out there. We're talking about simple organisms swimming in oceans, mossy creatures holding onto rocks, or the first signs of critters exploring their habitats. They might not be super brainy, but they leave their mark. Plus, they could be way more common and easier to find in our galaxy. Now take Earth, for example. There's a theory that our atmosphere used to have a lot of oxygen floating around. But oxygen is a bit wild and doesn't stick around for too long. It either escapes into space or bonds with other elements, changing into different things like carbon dioxide. Then, around 2 billion years ago, single-celled organisms decided to gobble up carbon dioxide and burp out oxygen, completely changing Earth's atmosphere. Life here transformed the very nature of our planet. And guess what? We can actually detect changes like that on other planets. Here's how. When we look at faraway planets called exoplanets, sometimes they cross in front of their parent stars. As the star's light passes through the planet's atmosphere, it gets all mixed up with different elements and molecules in the air. And you know what happens? The light changes its flavor and color in a special way. So imagine you had a glass of lemonade and you added some fruit juice to it. The lemonade would taste different, right? Well, it's kind of like that with exoplanet atmospheres. When we see the star's light that has traveled through the planet's atmosphere, it gives us clues about what's in the air and how it's different from just the star's light alone. So by studying these changes in light, we can figure out what kinds of elements and molecules are present in the atmosphere of a faraway planet. It's like a cosmic chemistry experiment, and it helps us learn more about whether there might be life out there. So right now, we can only study the atmospheres of big planets that orbit really close to their stars. But don't worry, NASA's Transiting Exoplanet Survey satellite is on the case. It's finding lots of interesting planets that we can check out more closely with the super-powered James Webb Space Telescope. This amazing telescope can even sniff out if there's too much carbon dioxide on other worlds. And okay, let's be real, our first contact probably won't be as flashy as in the movies. No exchanging secret codes or figuring out ET customs. We won't be chatting about funky bodies or habits either. Instead, the first hint of life out there will most likely come as a little wiggly line on a graph. It shows us that living creatures have really shaken things up on their home planet. Even simple life forms can have a big impact on their environment and leave behind a noticeable trace. Sure, it might not be as wild as battling space robots or epic adventures, but imagine this. Finding any kind of life beyond Earth would be huge. We'd be calling home, sending messages like, "Guess what? We're not alone in the universe." It would be an historic moment we're celebrating. And by the way, we've already begun to find organic molecules in space. It's not a full-fledged life as we imagine it, but it's still pretty neat. For example, we've already started to find organic compounds on Mars. And there's a teeny tiny chance that Mars once flourished with plants, and maybe even animals. This is just a possibility, but if it turns out to be true, it would show that the presence of living organisms in the universe is not as rare as it seems. The search for life in the universe is like a great detective game. We thought that finding it would be easier because they could do cool stuff like blasting radio signals or transforming their whole solar system. But looks like, in reality, things are much more complicated. Nevertheless, we shouldn't give up. Let's keep searching and hoping that this new study about radio signals brings some results. Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour, as faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists used space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did the zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there. They're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space. Thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow!